This problem also involves delta H, and it's asking about how many kilojoules per mole was released in this reaction. It is a reaction of two aqueous solutions. We're reacting hydrochloric acid with sodium hydroxide. So that's going to end up producing sodium chloride and water. Now, this is a very simple acid-base reaction. It's already balanced. Everything has a 1-to-1 mole ratio. And you can expect that level of problem in this class in particular. So, I have 1 molar solution of hydrochloric acid, and I have 50 milliliters of it. And I also have the same thing for the NaOH. Okay, so again, we're going to do this in 2 steps. This one's a little different since it is an acid-base reaction. Generally, we do find kilojoules per mole, but it's kilojoules per mole of water. So that is something that we'll have to do, but we'll deal with that in a minute. So, first part, Q equals MC delta T to get our kilojoules part. Now, one of the things that you have to, one of the tricks to doing these problems is you have to understand that 1 molar solutions are pretty dilute. And in being pretty dilute, that means they're made mostly of water. So that means we can use the density of water and the specific heat of water. I have 50 milliliters of hydrochloric acid solution, which is mostly water, and I have 50 milliliters of the NaOH. Those things are the ones we're checking the temperature change of. So both of those need to go into my mass calculation. So 50 milliliters plus 50 milliliters is 100 total milliliters. And because these are very dilute solutions, the density of water is 1, and we can apply that here. That is 100 grams. So we're going to use that in Q equals MC delta T, 100 grams times the specific heat, and because these are dilute solutions, we can use the specific heat of water, joules per gram degrees C. Now both of these started out at 22.5 degrees C, and then they ended up at 26. So that's a temperature change of 3.5 degrees C. Work out this problem, and I end up with 3 sig figs, 1460 joules, which if we convert to kilojoules, just moving that decimal place over, and that's joules, not 5, and I got 1.46 kilojoules. Alright, now to get the moles part. This should be relatively easy since we are just coming off of acids and bases, and you know that if you have molarity and volume, all you have to do is multiply those together. But the volume has to be in liters, so that would be 0.05 liters, and if you multiply that by 1, you end up with 0.05 moles of hydrochloric acid. The same thing applies here. This is 0.05 liters, and so if I multiply molarity times liters, I get 0.05 moles. Now this is a kind of an odd problem because we end up with the exact same amount of moles of both reactants. What we're really trying to do here is find the limiting reactant. It is going to be the one with the least amount of moles. Well, they have the exact same, so we're just going to pick one. Otherwise, you would go with the limiting reactant, the one that had the least moles. Now, this is a 1-to-1 mole ratio because we're trying to do moles of water. And so if we just take hydrochloric acid and compare it with water, it is a 1-to-1 mole ratio. So if I have 0.05 moles of HCl, I'm going to form, it's a 1 mole HCl to 1 mole of water formed. And so I'm going to end up with 0.05 moles of water. So now I can take my delta H, which is going to need to be in kilojoules per mole. I'll take my kilojoules and divide by my moles. Moles of water, 0.05 moles. And I end up with 29.2 kilojoules per mole. And I'm almost done here. All I have to do now is decide whether this is an endothermic reaction or an exothermic reaction. Well, the temperature went from 22.5 to 26, so the temperature went up. That means it is releasing heat, so we have to make that negative to make it exothermic. And that's how you do a problem like number 3 on the specific heat worksheet.